So that brings us back up to lab 12. And I mentioned that it's kind of complicated. It actually, what logic bundles do is, what we're going to use it for is to create two programs, one at the VAV level that is basically points that we want to be able to see in an air handler level program. And then we'll create the second air handler level program that looks at that VAV data and does things like average the zone temperature and heating requirement and counts how many alarms are active. And so that's a concept referred to as logic bundles. And we've already assigned the AHU tag to our controllers. We did that so that we could create those AHU refs so the VAVs know which air handlers are supplying them with air. And so it goes on to say we create one program first at the VAV level to create the list of points that the air handler program can see. And then we'll create that air handler program to look at those VAV points and then manipulate them as needed. So the first step is to create a VAV level program. And there's not actually going to be any, we're not going to drag any blocks on. It's just to basically create the list of points. So step one says we're going to go nav to the VAV level. So go ahead and go to project view, make sure you're logged in as a super user, open your project, and then nav to a VAV in the blue bar, and then do menu, logic builder, new. And then it says you can name your program VAV values. The description, you don't really need one. I don't know if I've ever really looked at the description after I've created it, but it's there if you like. Program on, as we saw before, that says which equips should this program run on. So every equip tag does a VAV. And then in the points list, it says which points do I want basically the air handler to be able to look at. And if you don't see VAV points, and if it doesn't say equip in VAV in the program on filter, you probably didn't navigate to a VAV before you did menu, logic builder, new. And so it says make sure the wall sensor is connected. That's just to make sure we have a good value. We don't have our training kits with us, but we do have good values. So we can step 4. And then it says pick high zone temp alarm, heating requirement, and zone temperature. And I'm actually going to choose low zone temperature alarm because we actually have a low zone temperature alarm already active, I believe. So let's do low zone temp alarm, heating requirement, and zone temperature. So low zone temp alarm, zone temperature, heating requirement. So those are the points that we're going to create. Did everybody find those 3 points in their VAV program?
Yeah.
Okay, so click OK. Your program's been created. Click OK. You don't even really need to open it for editing, but notice the variable names are slightly different here. There's always start with a lowercase letter, and they're always one word. And if you click edit, you will see those same names here. So I'm just going to capture that just so that we can see that, because we are going to need to type those names in exactly to match in our air handler level program. So there's really no programming. We're not dragging any blocks out. We're basically creating a grid of points. And so now once you've done that, it says look at the names of your points. And then we want to nav to an air handler level controller and create a logic builder program for the air handler. So I'm going to choose floor 1, air handler 5, because air handler 5 is my first floor air handler. Menu, logic builder, new. because this is an error handler level program. And then it says give it a name of VAV rollup. The program's going to run on every equip tagged as an AHU. And then in the points list, we're not going to actually pick any specific points from the error handler, but if you scroll all the way down to the bottom, you'll see a list of bundles. And the bundles are referring to VAV level programs. Because it knows about the relationship between the error handlers and the VAVs. So we're going to pick the bundle named VAV values, because these are the names of the programs that I've created for VAV equip. So does everybody see bundle VAV values at the bottom of the points list?
Yeah.
Okay. So we don't need any tags, project variables, or absolute points, so I'll click OK. And now my program's been created. I click OK again. Now I will click Edit to edit my VAV rollup program. And so notice I have one variable there named VAV values. It's got this G for a grid. And so one way to think of that is almost just like a table of points. So let's see, there's my list of points. So what you can think of that grid looking like is have an equip name, heating requirement, low zone temp alarm, zone temperature. And then I have an equip named VAV102. Its heating requirement might be 0%. Its low zone temp alarm might be on. Its zone temperature might be 65.7 degrees. VAV103 is also on the floor. It might have a heating requirement of 22%. Its low zone temp alarm might be off. Actually, this one's more likely to be on if it's got a heating requirement. And let's just set this a little higher. And this one might be 68.2 degrees F. And then the last VAV on the floor is 104. Its heating requirement might be 15%. Low zone temp alarm off. Zone temperature 71.2 degrees F. So it's just like a grid of points. Each VAV has values for each of the 3 points in the program. So once we've done that, then we're going to drag a get for the VAV values out onto the screen. So I'll do my get. Then in the block library, if you in the search box type the word grid, you'll get a grid select column. Then you can connect the VAV values square to the value square of the grid select. And then the column name is going to pick the point from the VAV program that you want to look at. So that's where I would have to very carefully type in the name of the point that matches exactly, including, no spaces, capital letters in the right place, all of those things. So in the first exercise, we are going to look at heating requirement in the column name field. So in this column name, and I wish the field was wider, and it would be even nicer if it was like a drop-down menu that showed you the point names, but it's not. So you just have to type carefully, HTG, all lowercase, capital R, and then lowercase EQUIREMENT. And you can use the arrow keys on your keyboard to kind of backtrack and confirm that you spelled it correctly. And then you're going to take that result of the grid select column, which will actually go look at all 3 of the VAV heating requirements and run it into the averaging block. So if you can either drag from result and click an empty space and choose the averaging block, or go to your block library and type AVG, drag an averaging block in. So if the result of the grid select column goes into the average, then it's going to look at all of the VAV's heating requirements, feed them into the averaging block to be average. This is a case I mentioned where the averaging block should only have one input. And so I mentioned earlier that if for some reason you added an input, you can't back your way out of it the way you can for the third one. And it won't work right if you have an unconnected slot. So if you ever added a second one and didn't need it, then you can right click and delete any links going into the averaging block, delete the averaging block by selecting it. You'll see a yellow border, press the delete key on your keyboard, and then just drag a new averaging block in. And so here we're going to add a local program variable that doesn't reside in the database. We won't see it in the equip tree. We'll just see it when looking at our program. And that limits its usefulness to some degree. We couldn't put it on a graphic or anything. But if we just wanted to be able to see what's going on, then it says in the right-hand menu, click on Add Variables to add a new number variable called Average Heating Requirement. So that means go to the right side here where it says Add Variables. And then we're going to choose the var to create and add a project variable. We'll give it a name like AVE HTG REQ. It is a program variable. Data type should be number. Click OK. And then the default value, it says give it a value of -1. And the reason I like to use -1 here is if all of the VAVs had a heating requirement of 0%, the average would be 0. And if my default value is 0, I don't necessarily know if it's 0 because it's the default or because the calculation gave me that number. If I make my default value -1 or something that's not between 0 and 100, then I know when I see a calculated value between 0 and 100, that's a result of the calculation and not just because it was the default value. So that's default value -1, hit apply. Now we've got that new variable, click OK. And it looks just like any other point in here, even though it's not a live data point in DB Builder, it is a point that I can manipulate in the program. So I'll drag a set for the new average heating requirement number. And then I'll take the result of the average into the 2 of this new set block. And then routine start, when it triggers every second, it will trigger the set. So once you build all that out, you can click the Save Disk icon to save your program. And then we want to see what this average heating requirement does. It'll take a few seconds to update the first time. And there's 33%. Did you guys both get something between, yours is probably 33 as well because we're looking at the same controllers?
Yeah.
Okay.
Mm-hmm.
If you didn't see it, it's usually because either you didn't save the program or the column name was not typed in correctly. That's usually the reasons why you would see that number not update.
No, it's not 50. Yeah, I get one.
Okay. Yeah, that's fine. They may change, and that's okay. The number, as long as it's not -1, essentially, that means the program is calculating it. And so what I want you to take some time to do, I'll give you a few minutes, and this is just to kind of work a little bit more independently to get some more practice with these logic bundles, is to repeat steps 15 through 18 to calculate the average zone temperature. And it'll look something like this in step 20 when you're done. So you can add a new grid select column take your VAB values in and give it the name of zone temperature, where again, you have to make it very carefully match. So all one word, all lowercase except the first T in temperature. Run it through a new averaging block, add a new program variable named average zone temp, and then take the results of the average, link it into the two, and then have the first set trigger the second set, and then save your program and see if you get a good average calculation. So you may not get it all, but it's good practice to try and do it working more independently. I will go ahead and build mine out, and then let me know if you have any questions along the way. So again, a different way, just to show you, to add the grid select column without just dragging it in. One way to do that is just to click as if you're going to drag somewhere, click an empty space, type the block that you want to connect to, grid select column, and click OK. Then the advantage of that is you don't have to drag from the block library, and it establishes the link for you. So then this will be zone temperature. In fact, I'll type it wrong just so you can see what happens when it's not correct. I'll just type zone T. Then again, to link it to an average block, rather than dragging across, you can just take the result, click in the empty space, type AVG, choose the average block, and OK. The advantage again is that you don't have to drag from lower left, and the link is already established. And in fact, you can do that with variables too. If I take the result and click into empty space, I get this same option. And this is the way you can link to what we call an absolute point, which is another point perhaps in a different equip in the database. But in this case, we just want to choose a variable. We're going to add a new variable. And then I can give it a name like AVE zone temp. It is a program variable. It is a number. I click OK. The default zone temp of 0 is OK because the average zone temp should never be 0. So I'm expecting a number in the 60s or 70s in terms of degrees. If I apply that, add at the point, and the advantage again is that it establishes the link. And then remembering that you have to trigger the flow, and the routine start triggers the first set. That set triggers the second set. And so now when I save it, it's not going to work because my grid select column name is incorrect. If I click save, it's not obvious that there's a problem. There's not anything that jumps out that says your column name is incorrect. But the fact that the average zone temp doesn't change from the default value, or actually it shows NA. It was 0, it was NA. That's a sign that there's a problem.
Yeah, I don't have.
So now if I go.
Look here.
Yeah. So now if I fix my column name to be zone temperature, that's all lowercase, no spaces, and it's a capital T, the first letter in temperature. Now I click save, give it a few seconds, and then I should see this average zone temp. Now I see there's a number in there.
There you go.
And your numbers probably are similar. So typing that name in is probably the hardest part, or it's not even the most important, but that's a common error, is that the column name is entered incorrectly. So the last part of this lab, it's a little odd too, but instead of just averaging, we're going to count alarms, and we picked low zone temp alarm instead of high because I think I do have some active low zone temp alarms. So I want to see it count something other than 0. So we're going to do something similar, and we're going to use a grid select column, and then we're going to choose the point called low zone temp alarm. But then instead of running it into an averaging block, we're going to run it into a count block. And the count block has this thing called the iterator. And step 21 says you can add a string variable named IT for the iterator with a default value of 0. And I'm not quite sure why it works, but I know that it works. And then what it'll basically do is step through the list, and every time it sees an on, it will increment that count by 1. So there's a string named iterator, and the result of the count will go in to trigger a set, or will go into the 2 of a set, and we're going to create a new program variable called, in this case, it'll be low zone temp alarm. So I'll do it the more traditional way, dragging in blocks, because I think that's probably how you'll do it more often when you're first getting started. So I'll bring in a new grid select column. And again, the same VAV values can trigger, get these to maybe overlap a little less. And the column name will be low, and then capital Z, zone, capital T, temp, capital A, alarm. So I got to carefully type that, low zone temp alarm. And then go back to the block library, type in the word count, run the result of the grid select into the value. And then to link to that iterator, I can add a variable, and I want to add a var with a name of IT. It is a program variable, but I want to change the data type to be string. And then when I click OK, the default value, it says, should be 0. The default value is 0. Instead of hello world, just type in 0. Hit apply. And now there's this new string named IT. So then I can take its get and link it into the iterator slot. And then I can add another project variable. I'll shorten the name up. I'll just call it low zone temp alarm count. I don't know how much shorter that is, but so low zone temp alarm count is a program variable. It is a number. I'll click OK. And here's where default value of -1 might be good, because the count should be 0 or higher. So if you started at -1, then as long as it's 0 or higher, then that's a good sign that the calculation is working. So there's my low zone temp alarm count. Take it, set. The count result goes to the 2 of the new set. And then the second set will trigger the third set.
Wait a second. Oh, it's get.
And then if I save that program, then my low zone temp alarm count should be, it actually happens to be 0 now, because I guess I don't have any low zone temp, but now that is counting.